So we have seen a domain means what? Domain will refers to the first element of each and every order pair, and range will refers to the second element of each and every order pair. Okay. After that we had seen what are the different properties of relations. So can you tell me just names of properties? We have seen five different properties. So what are those properties? Yes.
Reflexive, symmetric,
Yeah.
transitive,
Transitive.
irreflexive, and symmetric.
Okay. So first property was a reflexive, then symmetric, then transitive, then irreflexive and antisymmetric. Okay. So we have seen what is meaning of a reflexive property. So if your relation is containing any order pair as x comma x, like 1 comma 1 2 comma 2, then we can say that our relation is a reflexive relation. Okay. And that property must satisfies for all the elements of your set. Okay. Suppose we have defined any relation on set, and that set is containing three elements as 1 2 3, then your relation must contain order pairs 1 comma 1 2 comma 2 and 3 comma 3. Then only we can say that our relation is a reflexive relation. Okay. After that we had seen second property, that is a symmetric property. Let me share my screen first. Check whether screen is visible.
Yes, ma'am.
Yes,
Okay.
ma'am.
So for this symmetric property, we have seen if there is any order pair x comma y, then your relation must contain order pair y comma x. Then only we can say that that relation is a symmetric relation. Means what? There must exist reverse of each and every order pair in your relation. Then only that relation is a symmetric relation. Then after that we had seen what is a transitive relation. So for this transitivity we have taken three elements as x, y and z. So what is meaning of this transitive property? If x is in relation r with y and y is in relation r with z, then we can say that x is in relation r with z. Then only we can say that that relation satisfies a transitive property. हॅलो.
हा मॅम, आपला फोर्थ चॅप्टर चालू आहे आणि आमचं अजून फर्स्ट सेकंड थर्ड चॅप्टरचं रायटिंग झालं नाहीये. मग तुम्ही ते असं कोणत्याच विषय पहिलं दुसरा चॅप्टर चालू आहे मॅम, आणि हे खूप फास्ट चालू आहे मॅम, त्याच्यामुळं कव्हर करण्यासाठी टाइम नाही भेटत.
म्हणजे फास्ट झालं म्हणजे काय, स्पीड जास्त होते, काय होते?
हा स्पीड
येस मॅम.
मग हे मी तुम्हाला आधी पण विचारलं होतं की स्पीड जास्त होते का, तुम्हाला काही प्रॉब्लेम्स असतील तर सांगा.
हा मॅम, तर मग काल मीटिंग झाले एक, तर त्या मीटिंग मध्ये रिव्हिजन घ्यायला सांगितलंय मागच्या चॅप्टरचं.
रिव्हिजन फॉर दिस चॅप्टर?
मॅम ह्या वीक मध्ये थोडंफार रिव्हिजन घ्यायला सांगितलंय, कारण आम्ही आमचं मागचं सगळं जे राईटअप आहे ते कम्प्लीट करू शकू.
चालेल, पण कुठल्या पॉईंटची रिव्हिजन तुम्हाला पाहिजे ते मला सांगा, मग त्यानुसार आपण शेड्यूल करू.
Madam, from first chapter.
From first chapter? No, that is not
Yes,
possible to
yes,
revise
ma'am.
whole content.
Madam, right up first chapter पासून राहिलेले काही पुढे.
Hello, your
Right up
voice is
करण्यासाठी
not clear. Can you repeat it?
हॅलो मॅम.
हां
मॅडम राईट टाईप राहिले सगळ्यांचं, त्यामुळे फर्स्ट चॅप्टर पासून रिव्हिजन घ्यायला सांगितलं.
मग रिव्हिजन आज घ्यायचे की आज नवीन कंटेंट चालू करायचे?
मॅम रिव्हिजन घ्यायची आहे.
रिव्हिजन घ्यायचे, ठीक आहे चालेल. मग आज फर्स्ट चॅप्टरची रिव्हिजन घेऊयात का?
येस मॅम.
Yes, ma'am.
येस मॅम.
ओके.
हॅलो मॅम.
हां हॅलो.
मॅडम रिव्हिजन घेतलेत का, म्हणजे त्यांना पण टाइम द्या रायटरसाठी.
टाईम म्हणजे कसं देणार तुम्हाला? ते आता तुमच्या घरीच कंप्लीट करावं लागेल ना. ड्युरिंग लेक्चर आय कांट
मॅडम
परमिट
एक
यू टू.
पॉईंट शिकवला,
हां
पॉईंट झाला की नंतर थोडा वेळ थांबा.
So just give me 5 minutes. So I will take notes of unit number 1 here. Hello. Hello.
Yes, ma'am.
Currently
Yes, ma'am.
notes for unit number 1 are not with me. So today we will continue with unit number 4, some points, and after that from next lecture onwards we will take revision. Is it fine?
Yes, ma'am.
Okay. Okay. So last lecture we have seen properties of relations. In that we have seen first property is reflexive, then symmetric, then transitive, then irreflexive. Means what? There should not be any element x comma x belongs to R. And last one was antisymmetric. So if your x is in relation R with y and y is in relation R with x, then x is equals to y. If this condition is satisfied, then only we can say that our relation satisfies antisymmetric property. Okay. So today first of all we have to solve some examples based on these points, then we will see next point. Okay. So question number 1 is given. Define a relation between two sets A and B where contents of A 5, 6, 7 and B x and y. Okay. So between these two sets we have to define a relation. So what we have seen with respect to relation? Relation is a set of order pairs. Okay. So in order to define the relation between these two sets, we have to form a set of order pairs. So first order pair we can write first element is from set A and second would be from set B as 5 comma x. That is the first order pair. Then second order pair 5 comma y. Now here we have just completed first element as a 5. Now take the next element. So for that next element 6, 6 comma x, 6 comma y, and then 7 comma x, 7 comma y. Then only we can say that this relation or this set of order pairs defines a relation R between set A and B. Okay, just we have formed a set of order pairs from these two sets. Hello, have we understood how to define any relation? Hello.
Yes, ma'am.
Yes,
Okay.
ma'am.
Now, second example is given. Consider a relation S is equals to order pair 1 comma 2, order pair 3 comma 4, A comma T and P comma Q. So here for this relation we have to find out domain and range. Okay. So what is the domain of this relation S? And that is defined by D of S. D is for domain. So what we have seen, domain will refers to first element of each and every order pair. That's why now check for which one is the first element from every order pair. 1, 3, A, T. So this is the domain of given relation S. Now when we have to find out range of relation, we have to refer to the second element. So that second element is 2, 4, T, Q. Okay. So this is the range of this relation S. So have we understood the concept domain and range of relation? Meaning समजलं का डोमेन अँड रेंजचा?
No, ma'am.
नाही समजलं? Okay. Why this one is called as a relation? एस ला आपण रिलेशन का म्हटलं बिकॉज दिस इज कन्सिस्ट ऑफ सेट ऑफ ऑर्डर पेयर्स. चेक करा 1 2 3 4. So here 4 order pairs are there. That's why this relation or this S is called as relation. ओके. आता डोमेन म्हणजे काय असतं, प्रत्येक ऑर्डर पेअर मधला पहिला इलेमेंट हा डोमेन असतो तसा. आता चेक करा पहिली ऑर्डर पेअर जर आपण कन्सिडर केली तर त्याचे इलेमेंट काय आहेत 1 and 2. सो हियर दिस 1 इज ए फर्स्ट इलेमेंट अँड 2 इज ए सेकंड इलेमेंट. सो 1 विल रेफर टू डोमेन, अगेन 3, अगेन A and P. म्हणजे प्रत्येक ऑर्डर पेअर मधला फर्स्ट इलेमेंट आपण डोमेन कन्सिडर करणार आहे. दॅट्स वाय डोमेन ऑफ दिस रिलेशन S इज सेट विच इज including 1, 3, A and P. Okay, now understood what is domain?
Yes, ma'am.
Okay, and for this range we have to take second element all the time from all order pairs. So it will consist of 2, 4, T, Q. That's why range of S is given as 2, 4, T, Q. Okay, so this is the concept of domain and range. Now here in the third question, two sets are given P and Q. Okay, so we have to find out P union Q, P intersection Q, domain of P, domain of Q, domain of P union Q, range of P, range of Q, range of P union Q. Okay, first of all we will find the answer for all these questions, then we will show this given statement. Okay, so first relation is P, second one is Q. Now first question they have asked, find out P union Q. So what is meaning of union? In set theory we have seen different operations on set like union, intersection. So what is meaning of union? Union मध्ये काय करतो आपण?
The element
काय करतो? हॅलो,
combining the two sets.
yes, we are going to combine the order pairs from both the relations. That is correct. So P union Q will consist of order pairs from both the sets, from P as well as from Q. So order pair 1, 2, 2, 4, 3, 3. So here we have taken all the order pairs from first relation P. Now we are going to take order pairs from second relation as 1, 3. Now 2, 4 is repeated here because that is present in P also. So it is not required to write this order pair twice. We can consider only once. And second one is 4, 2. So answer for P union Q is 1, 2, 2, 4, 3, 3, then 1, 3 and 4, 2. Okay. Then what is the answer for P intersection Q? So for this we have to check whether there is any order pair which is common between P and Q. Now check here. I think order pair 2, 4. This is the only order pair which is common between P and Q. That's why answer for P intersection Q is order pair 2, 4. Okay. Now can you tell me what is the domain of P? In the last example itself we have seen how to find out domain and range. So what is the domain of P?
One comma 2, 3.
Is 1, 2, 3. Because we have seen domain always refers to first element from each and every order pair. Then what is the domain of Q?
1, 2, 4.
Yes, 1, 2, 4. Then domain of P union Q. So first of all we have to check what we have written in P union Q. So this is the answer for P union Q. Again, in order to find out domain of this P union Q, again we have to take first element of each and every order pair. So here 1, 1, 2, 3, 4. But 1 is repeated, so we are going to write it once. That's why domain of P union Q is 1, 2, 3, 4. Okay. Then next, range of P. So what would be the answer for range of
2, 4, 3.
Yeah, 2, 4, 3. Because range always refers to second element of each and every order pair. Then range of Q.
3, 4, 2.
3, 4, 2. Correct. Then range of P union Q. Again, first of all we have to check
2,
for
3, 4.
2, 3, 4. Correct. Yeah. Now, in the next question, they have asked, show that domain of P union Q is equals to domain of P union domain of Q. Okay. So here we have find out what is the domain of P union Q, and that is consist of 4 elements as 1, 2, 3, 4. Okay. Now check here. We have to show that this domain of P union Q, this is equivalent to or equals to domain of P union domain of Q. Now take union between these two, domain of P and domain of Q. So what is the answer for this union operation? If there is
1, 2, 3, 4.
Yeah, 1, 2, 3, 4. Because if there is any repetition, we are not going to consider it. That's why 1, 2, 3, 4. So, in this way, we can show that domain of P union Q is equals to domain of P union domain of Q. Okay. So, in the next question, they have asked a range of P intersection Q is subset of range of P intersection range of Q. Okay. So first of all we have to find out what is the range of P intersection Q. So can you tell me? So here we have written P intersection Q. So what is the range for this P intersection Q?
4.
4. Yeah. So here we have to show that this 4 is a subset of range of P intersection range of Q. So range of P is 2, 3, 4 and range of Q is again 2, 3, 4. Okay. So if you take intersection between these two, you will get answer as 2, 3, 4 only, because all the elements are common between these two. And 4 value for P intersection Q, that is the range of P intersection Q, is set 4, and value for range of P intersection range of Q is set 2, 3, 4. So here we can directly say that 4 is a subset of set 2, 3, 4. Okay. So subset से meaning माहिती है का? समझले का? Subset means what? Why this set 4 is called as subset of set 2, 3, 4? Because 4 is a one member which is present in this whole set as 2, 3, 4. That's why we can say that set 4 is a subset of set 2, 3, 4. Likewise, we can say that set 2 is a subset of 2, 3, 4, or set 3 is a subset of 2, 3, 4, or we can say set 2, 3 is a subset of set 2, 3, 4. Okay. म्हणजे त्यातले काहीतरी मेंबर पाहिजेत फर्स्ट सेटमध्ये, then only we can say that first set is a subset of second set. Okay. So here 4 is present here and that is present in this whole set also. That's why set 4 is a subset of set 2, 3, 4. Have you understood How we have proved this?
Yes, ma'am.
Yeah. So next question is question number 4. What is the range of relations? And relations are given. S is equals to order pair x comma x square for every x belongs to n. And another relation is given T, where T is equals to order pair x comma 2x for every x belongs to n. So here n is a natural number and that will include numbers from 0 to n. Okay, 0, 1, 2, 3 and so on. So here we have to find out S union T and S intersection T. Okay. So first of all, we have to find out what would be the different elements. Those will be included in these relations S and T. Okay. Now consider first relation S. So S is given as, it will consist of order pairs x comma x square. Now first we are going to put the value for x as 0. जर आपण इथं 0 पुट केलं तर फर्स्ट ऑर्डर पेअर काय येईल 0, 0 square. So it will give you order pair 0, 0. Okay. Then if you consider the value for x as 1, then 1, 1 square as 1, 1. Check here. First order pair we got. If you put the value for x as 0, it will give you order pair as 0, 0. If you put value for x as 1, so it will give you 1, 1. Then next element is 2. So if you put value for 2 is x is 2, then 2, 2 square, that is 4. Again 3, 9, 4, 16. So likewise you will get the order pairs for relation S, because it includes all the order pairs such that x, x square. Okay, and that x belongs to n. That's why we have written the relation S as order pair 0, 0, 1, 1, 2, 4, 3, 9 and 4, 16 and so on. Now next relation T is given, and that is consist of order pairs x, 2x for every x belongs to n. So again for this relation T, we have to put the value for x as 0. जर 0 टाकलं तर फर्स्ट ऑर्डर पेअर काय येईल काय ना रे 0, 2 into 0, that is equals to 0 only. So first order pair would be 0, 0. Okay. Now next is 1. So if you put the value for x as 1, so it will give you answer as order pair 1, 2. Again, if you consider the value for x as 2, then it will give you order pair as 2, 4. Then 3, 6, 4, 8 likewise. So here just we have defined the relations S and T. Now we have to find out what is the union between these two relations S and T. So S union T, so it will include all the order pairs from S and T. So likewise 0, 0, 1, 1, 2, 4, 3, 9, 4, 16, then 1, 2, 2, 4, 3, 6, 4, 8 and so on. Just here we have considered some of the order pairs. Okay. Now we have to write what is the intersection between S and T. Means what are the order pairs common between S and T. So now check for these two relations. What are the order pairs common? First order pair is 0, 0 and second order pair is 2, 4. So this is the answer for S intersection T. So likewise, from any given definition of relation, we can find out what are the actual elements of that relation, and we can perform any kind of operation like union, intersection on those two relations. Have you got this question? How to solve these kind of problems?
Yes, ma'am.
Yeah, fine. Okay, so in the next question, they have given one set, and that set is consist of 4 elements, 1, 2, 3, 4. Then they have defined two relations R and S. So R is consist of order pairs x comma y for every x belongs to set X and y belongs to set Y, and x comma y is an integral non-zero multiple of 2. So this is very important case in order to find out order pairs of relation R. So we have to include such a order pairs for which x comma y is integral non-zero multiple of 2. This condition is comes true. Okay. Now again second relation S is given, and that is consist of order pair x comma y such that x belongs to set X and y belongs to set Y, and x minus y is an integral non-zero multiple of 3. Okay, and then we have to find out what is the value for R union S and R intersection S. So first of all we will find out order pairs for these two relations. Okay. So what is the set given? Set X is given, and that is containing 4 elements, 1, 2, 3, 4. Now we have to define relation R. आता काय म्हटले त्यांनी, त्या रिलेशनमध्ये अशा ऑर्डर पेअर असणार आहेत ज्याच्यासाठी x मायनस वाय is an integral non-zero multiple of 2. This condition is satisfied. आता बघा, if you consider any order pair like 1, 3. आता 1, 3 घेतलं तर ह्यामध्ये x काय असणार आहे? त्यांनी काय म्हटलं, फॉर एव्हरी ऑर्डर पेअर x, y means what? X is a first element of that order pair and y is a second element. Okay. आता जर आपण ऑर्डर पेअर 1, 3 घेतली, then your x will refers to 1 and y will refers to 3. Now check what is the value for x minus y? That is 1 minus 3, and that comes as minus 2. So minus 2 is a multiple of 2. Minus 2 असेल तर multiple of 2 आहे ना तो. 2 into minus 1, that gives you minus 2. That's why this order pair 1, 3 belongs to relation R. Okay. Again, if you consider 3, 1, again we have to apply this condition x minus y. So here the value for x is 3, value for y is 1. So 3 minus 1, it gives you 2. So 2 is a multiple of 2, as 2 into 1 is 2. That's why this order pair is included here. Again we have to find another order pairs like 2, 4. So 2 minus 4, answer is minus 2, and that is multiple of 2. Again 4 minus 2. If you consider this order pair 4, 2, 4 minus 2, answer is 2. And so this is also multiple of 2. 2 into 1, 2. Okay. So all these order pairs are such that x minus y is a multiple of 2, non-zero multiple of 2. Okay, that's why we have included these 4 order pairs in relation R. Hello?
Yes,
समजलं
ma'am.
का रिलेशन R कसं घेतलंय?
Yes, ma'am.
Okay. So likewise, can you tell me how we can define relation S on this set X?
In set of here. 1, 2.
आता इथे कंडिशन काय दिले बघा, x मायनस वाय इज अन इंटिग्रल नॉन झिरो मल्टिपल ऑफ 3. 3 चे मल्टिपल्स पाहिजेत ते. हां, कॅन यू ट्राय?
Ma'am, shall I tell? 1,
हॅलो, 1,
2.
1, 4.
Oh, sorry, ma'am. 1, 4.
येस, 1, 4 अँड 4, 1. बिकॉज 1, 4 घेतलं तर काय ना, 1 मायनस 4 दॅट इज इक्वल्स टू -3. हिअर दे हॅव रिटन नॉन झिरो, म्हणजे काय, आपण निगेटिव्ह नंबर पण ह्यात इन्क्लूड करू शकतो. दॅट्स वाय 1, 4 बिलॉंग्स टू एस. अगेन 4, 1. 4, 1 घेतलं तर काय येणार, 4 मायनस 1 दॅट इज इक्वल्स टू 3 अँड 3 इज ए मल्टिपल ऑफ 3. दॅट्स वाय here relation S includes two order pairs. Now we have to find out union between these two relations. So in order to find out union, we have to combine the order pairs from relation R and S as 1, 3, 3, 1, 2, 4, 4, 2, 1, 4 and 4, 1. Just we have combined the order pairs from relations R and S. Okay. Now we have to find out what is the intersection between these two relations. आता intersection साठी काय चेक करणार? Check whether any order pair is common between relation R and S. आता common काय आहे का या दोघांमध्ये? नाही आहे. That's why its answer is 5. 5 means what? Empty set. So answer for R intersection S is 5. Have you understood this problem? Hello?
Yes, ma'am.
Yeah. Okay. So now we will see the next example. Let L denote the relation less than or equals to and D denote the relation divides, where X is in relation D with Y means X divides Y. Both L and D are defined on set 1, 2, 3, 6. Then write L intersection D. So this is our given question. So set X is given. So first of all we have to find out the relations L and D. So what is meaning of this L? Relation L मध्ये काय असणार आहे? Such a order pairs those follows the condition less than or equals to. जे हे कंडिशन सॅटिस्फाय करणार आहे तेवढेच ऑर्डर पेअर आपण घेणार आहे. अँड वी हॅव टू डिफाईन दिस रिलेशन्स ऑन सेट 1, 3, 6. 1, 2, 3, 6. ओके, ह्या सेटवर हे रिलेशन्स आपल्याला डिफाईन करायचे. आता लेस दॅन इक्वल्स टू म्हणजे काय? इफ यू कन्सिडर एनी ऑर्डर पेअर whose first element is either less or equals to second element. So we have to find out group of such order pairs. आता जर आपण first element घेतला 1, so we can define order pair like 1, 1 because first element 1 is equals to second element. So it satisfies this given condition less than or equals to. एक तर तो फर्स्ट एलिमेंट लेस असला पाहिजे सेकंड एलिमेंटपेक्षा, अदरवाइज इट शुड बी इक्वल्स टू सेकंड एलिमेंट. दॅट्स वाय ऑर्डर पेअर 1, 1 इज included. Likewise we can take order pair 1, 2. So here 1 is less than 2. Again 1, 3, 1, 6, 2, 2. Here value of 2 is equals to 2. Then 2, 3, 2, 6. Then for these 3 we can include 3, 3 and 3, 6. And for last element 6 we can write only one order pair as 6, 6. So this is the relation L. Now we have to define the second relation D. आता D साठी त्यांनी कंडिशन काय सांगितली? D denote the relation divides. X dy means what? X divides y. So here we have to find out such order pairs whose first element divides second element, like order pair 1 comma 1. 1 divides 1. Okay. Again 1 divides 2, 1 divides 3, 1 divides 6. Again, if you consider element 2, 2 divides 2, 2 divides 6, then 3 divides 3, 3 divides 6 and 6 divides 6. चेक करा, या सगळ्या ऑर्डर पेअर मधला फर्स्ट एलिमेंट divides second element. This condition comes true. That's why we have included all these order pairs in relation D. Have we understood how we have defined relations L and D? जी कंडिशन तुम्हाला क्वेश्चन मध्ये विचारली त्या कंडिशन नुसार तुम्हाला ते रिलेशन डिफाइन करायचे. अगेन व्हाट इज मीनिंग ऑफ रिलेशन? वी हैव टू जस्ट form a collection of order pairs those satisfies given condition, so that will form your relation. So here we have taken relation L and D. Now in this question they have asked what is the intersection between L and D. So again, in order to find out this intersection, we have to look for common elements or common order pairs like 1 comma 1. So here 1 comma 1, 1 comma 1, that is common. Again 1 comma 2, that is common. 1 comma 3, 1 comma 6, then 2 comma 2, then 2 comma 3, no, that is not here. Again 2 comma 6 is common, 3 comma 3, 3 comma 6 and 6 comma 6. So all these order pairs will be included in L intersection D. Have we understood this problem? Hello. If you have any doubt, you can ask me. So I will repeat it.
Madam, D condition not understanding.
Hello. Your voice is not clear. Can you repeat it again?
Ma'am, D condition is not understanding.
Which one?
D. D.
D. Okay. So I will repeat it. So what they have given for D? D denotes a relation divides. D कुठला relation define करता? Divides. And that is between any order pair x, y. So कसं असणार? x divides y. म्हणजे आपल्याला असं रिलेशन डिफाइन करायचं आहे ज्यामध्ये त्या ऑर्डर पेअरचा पहिला इलेमेंट सेकंड इलेमेंटला डिवाइड असणार आहे, म्हणजे डिवाइड करेल. लाईक इफ यू कन्सिडर ऑर्डर पेअर 1 comma 1, 1 divides 1. चेक करा, 1 by 1 आन्सर काय येतं? 1. दॅट्स वाय वी कॅन कन्सिडर दिस ऑर्डर पेअर because this 1 divides 1. Again, if you consider second order pair 1 comma 2, 1 divides 2. Again 1 divides 3, 1 divides 6. आता 1 ने प्रत्येक हेलाच भाग जातो, प्रत्येक एलिमेंटला 1 2 3 6 मधला. That's why we have taken all these order pairs 1 comma 1, 1 comma 2, 1 comma 3, 1 comma 6. आता 2 साठी सेकंड एलिमेंट कोण आहे? 2. तर 2 साठी आपल्याला असे ऑर्डर पेअर फाइंड आउट करायचे ज्यामध्ये फर्स्ट एलिमेंट सेकंड एलिमेंटला डिवाइड करेल. ओके, लाईक वी कॅन कन्सिडर 2 comma 2. सो हियर 2 divides 2. अगेन 2 comma 3 आपण घेऊ शकतो का? नो, बिकॉज 2 can't divide 3. कम्प्लीट आपण काय म्हणतो मराठीमध्ये पूर्ण भाग जायला पाहिजे. तर 2 comma 3 घेतलं तर तसं होतंय का? नाही. That's why we cannot include order pair 2 comma 3. But if you consider 2 comma 6 is that order pair we can include because 2 divides 6. 6 by 2 घेतलं तर काय येतं आन्सर? 3 येतं. Means what? 2 divides 6. This is for element 2. आता नेक्स्ट एलिमेंट कोणतं आहे? 3. So for this element we can write order pair as 3 comma 3. Answer is 1. Okay, means what? Complete भाग जातोय. That's why we have taken that order pair. Again 3 comma 6. 3 comma 6 मध्ये पण काय होतं? 6 by 3 घेतलं तर आन्सर काय येतं तुमचं? 2 येतं. Means what? This order pair we can include. And for this last element we can write just one order pair as 6 comma 6. पहिल्या इलेमेंटने सेकंड इलेमेंटला पूर्ण भाग गेला पाहिजे तसेच ऑर्डर पेअर आपल्याला इथे इन्क्लूड करायचे सॉरी डिवाइड्समध्ये. सो दिस इज मिनिंग ऑफ डिवाइड वेअर फर्स्ट इलेमेंट डिवाइड्स सेकंड इलेमेंट. समजले का आता डिवाइडचं मिनिंग काय आहे?
Yes, ma'am.
हां so next question is given. Let R be the relation from X and that X is consist of elements 2, 3, 4, 5 to set Y which is consist of 4 elements 3, 6, 7, 10 which is the defined by X divides Y. Again here in this question that relation is a divides relation. Then first question they have asked write R as set of order pairs and find range and domain of relation R. Okay, म्हणजे काय इथं आपल्याला रिलेशन R फाइंड आउट करायचं आहे such that X divides Y. Again we have to define that relation between these two sets X and Y. म्हणजे कसं असणार आहे तुमचं फर्स्ट इलेमेंट त्या ऑर्डर पेअरचा सेट एक्स मधून असेल आणि सेकंड इलेमेंट सेट वाय मधून असेल. असे कुठले ऑर्डर पेअर आपल्याला लिहिता येतील? अँड दोज ऑर्डर पेअर्स शुड सॅटिस्फाय रिलेशन डिवाइड्स. नाउ चेक हियर. Consider the first element of this set X and that element is 2. Now we have to find out any another element from this set Y such that 2 divides that element. Like 2 comma 6 is our order pair consider केली. So here we can say that 2 divides 6 is. That's why we can write that order pair in this relation. Again we can write 2 divides 10. Like order pair 2 comma 10. Again 3 comma 3, 3 comma 6. Then if you consider 4, so is there any element for which 4 can divide? आहे का तसा कुठला element y मध्ये नाही आहे. So we are not going to write any order pair for this element 4. Now consider the next element. That element is 5. So here we can write 5 comma 10 because 5 divides 10. So here this satisfies this given condition divides. That's why this relation will include order pairs 2 comma 6, 2 comma 10, 3 comma 3, 3 comma 6 and 5 comma 10. Have we understood how we have defined this relation R?
Yes, ma'am.
Okay. So in the second question they have asked find the range and domain of relation R. आता रेंज म्हणजे काय असणार आहे? फर्स्ट की सेकंड एलिमेंट?
Second element.
element.
सेकंड एलिमेंट. आता रेंज साठी आन्सर काय येईल? 6, 10, 3 and 10. Okay, that is repeated. So we can consider 6, 10 and 3. So 3, 6 and 10. So this is for range. I think 3 is missing here. 3 इथं पाहिजे add करा because this 3 comma 3 here second element is 3. Now what is the domain? Domain will refers to first element. So 2, 3 and 5. So this is for domain of this relation R. Okay. So have we understood this problem?
Yes, ma'am.
Yeah, good. Next question. Let R be the relation in X, where X is consist of 5 elements 2, 3, 4, 5, 6, defined by X is in relation R with Y. This is equivalent to X minus Y is divisible by 3. Okay. So for this question I want answer from you. So here I have to define relation such that X minus Y, if you consider any order pair, then X minus Y must be divisible by 3. So can you tell me what are the different order pairs? कुठले ऑर्डर पेअर आपण कन्सिडर करू शकतो फॉर दिस रिलेशन आर?
2,5.
2 पासून स्टार्ट करा म्हणजे तुमचं सिक्वेन्स करेक्ट जाईल.
2,5.
2,5.
Yeah, 2,5 or we can write 5,2. Okay. Then next 2 order pairs we got as 2,5, 5.
3,6.
Yeah, 3,6 and 6,3. So this is the relation R. Here each and every order pair X minus Y is divisible by 3. That's why this is the answer for given relation. Okay. So next question is given. Set S is equals to all the numbers from 1 to 10 and relation R on S, where R is equals to set of order pairs X comma Y such that X plus Y is equals to 10. Then what are the properties of relation R? So जर तुम्हाला प्रॉपर्टीज फाइंड आउट करायचे आहेत तर फर्स्ट ऑफ ऑल यू हॅव टू फाइंड आउट what is the relation R, means what would be the different order pairs, those we can include in relation R. कसे फाइंड आउट करणार आहे? such that for every order pair X plus Y is equals to 10, this condition must come true. Which order pairs we can
1,9.
Yeah, 1,9 or which one? 9,1. Answer is same.
9,1.
Yeah, that is the first and second order pair. Now if you consider 2,
2,8.
8 or 8,2. Okay, so 1,9, 9,1, 2,8, 8,2, 3,7, 7,3, 4,6, 6,4 and 5,5. So all these are the order pairs, those defines relation R, because all these order pairs are satisfying condition X plus Y is equals to 10. Okay, now you have to tell me what are the properties are satisfied by this relation R. आपण बघितले there are 5 different properties of relation: reflexive, symmetric, transitive, irreflexive and antisymmetric. So out of those property, what are the different properties satisfied by this relation R? Now let us start with the reflexive property. Tell me what is meaning of reflexive?
Five, 5.
Yeah, 5,5 is here, but this relation is defined on set which is consist of elements from 1 to 10. मग फक्त 5,5 असेल तर हे रिफ्लेक्सिव्ह होणार आहे का? नाही आहे, बिकॉज व्हॉट वी हॅव सीन फॉर एव्हरी एक्स बिलॉंग्स टू दिस सेट एस देअर शुड बी ऑर्डर पेअर लाईक एक्स कॉमा एक्स. म्हणजे काय, त्या सेटमधल्या प्रत्येक एलिमेंटसाठी तशी ऑर्डर पेअर पाहिजे. म्हणजे जर आपण फर्स्ट एलिमेंट 1 आहे तर 1,1 पाहिजे, सेकंड 2 आहे 2,2 पाहिजे, 3,3, 4,4, 5,5, 6,6, Likewise, up to 10, 10. If all such order pairs are included in given relation, then only we can say that that relation is a reflexive relation. But here only one order pair is present out of those 10 order pairs, and that order pair is 5, 5. So this is not a reflexive relation. Are you getting this? Why it is not reflexive?
Yes, ma'am.
ओके, नाव चेक. आता हे रिफ्लेक्सिव्ह नाही आहे म्हटल्यावर आपण चेक करू शकतो कॅन इज इट इन रिफ्लेक्सिव्ह. इन रिफ्लेक्सिव्ह आहे का? मग इन रिफ्लेक्सिव्ह म्हणजे काय? एनी ऑर्डर पेअर एक्स कॉमा एक्स शुड नॉट बिलोंग टू रिलेशन आर. एक सुद्धा तिथं ऑर्डर पेअर नको ज्यामध्ये 1, 1, 2, 2 असे एलिमेंट असतील. मग हे इन रिफ्लेक्सिव्ह आहे का? नाही आहे इन रिफ्लेक्सिव्ह. वाय? बिकॉज ऑर्डर पेअर 5, 5 इज प्रेझेंट हिअर. आपण काय म्हटलं? त्या रिलेशनमध्ये एक पण तशी ऑर्डर पेअर नको आहे ज्यामध्ये एक्स, एक्स असेल, म्हणजे सेमच इलिमेंट असेल. पण इथे तो इलिमेंट आहे, ती ऑर्डर पेअर आहे. दॅट्स वाय दिस इज नॉट ए इन रिफ्लेक्सिव्ह रिलेशन ॲज वेल. म्हणजे ते रिफ्लेक्सिव्ह पण नाही आहे, इन रिफ्लेक्सिव्ह पण नाही आहे. नाउ चेक फॉर अनदर प्रॉपर्टी लाईक सिमेट्रिक प्रॉपर्टी. Check whether this one is a symmetric relation. If order pair and its reverse, if both are present in given relation, then only we can say that the relation is a symmetric relation. Likewise, 1, 9 आहे, मग याचा रिव्हर्स काय येईल? 9, 1. Yes, that order pair is present here. So check for next one. 2, 8, 8, 2. That is also present. 3, 7, 7, 3. 4, 6, 6, 4. 5, 5 चा reverse काय येईल? 5, 5 only. That is also present. Means what? We can say that this relation is a symmetric relation. Are you getting this? आपण काय म्हटलं? If x is in relation r with y, then y is in relation r with x. म्हणजे x आणि y ची फक्त पोझिशन अल्टर करायची आहे, स्वॅपिंग करायचे. जर तसे सगळे ऑर्डर पेअर्स प्रेझेंट असतील, देन ओनली वी कॅन से दॅट रिलेशन इज सॅटिस्फाईंग सिमेट्रिक प्रॉपर्टी, अँड हिअर दॅट कंडिशन बिकम्स ट्रू. दॅट्स वाय दिस रिलेशन आर इज ए सिमेट्रिक रिलेशन. नाउ check for whether this one is a transitive relation. ट्रान्सिटिव्ह मध्ये आपण काय बघितलं? If x is in relation r with y and y with z, then x must be in relation r with z. So what is your answer? Whether this relation is a transitive relation? No, because if you consider the first order pair 1, 9, then for this order pair we have to find such another order pair whose first element is 9. Okay, that order pair is here. So here 1, 9 and 9, 1. So here this 9, 9 will get cancelled. You will get order pair as 1, 1. Now check whether 1, 1 is available here in this relation. No, that's why this relation is not transitive. So now check for whether this one is a antisymmetric. Antisymmetric चे meaning काय बघितलं? If x is in relation r with y and y is in relation r with x, then x is equals to y. Okay. आता इथे बघितलं आपण 1, 9 आहे, 9, 1 आहे, बट इज इट true that 1 is equals to 9? No, that is not correct. जर दोन्ही ऑर्डर पेअर आहेत एक 1,9 9,1 म्हणजे ह्याचं मिनिंग असं नाही आहे 1 इज इक्वल्स टू 9. दॅट्स वाय दिस इज नॉट ए अँटीसिमेट्री. So this relation is only satisfying symmetric property out of 5 properties. Have you understood how we have checked what are the properties satisfied by given relation?
Yes,
Hello?
ma'am.
Yeah. Okay. Okay. In question number 10, here they have asked determine whether the following relations are transitive. Okay. Transitive आहेत की नाही ते चेक करायचे out of these 3 relations. So first relation 1,2 and 2,2. Now tell me whether this relation is a transitive relation. We have seen how to check transitivity of relation. First order pair is 1,2. Okay, so now we have to find out such a order pair whose first element is 2. Now there is one order pair 2,2 whose first element is 2. So these 2 and these 2 will get cancelled. You will get answer as 1,2. Now that 1,2 is available in given relation. So this relation R is a transitive relation. ट्रान्सिटिव्हिटी कशी चेक करायची समजलं का? एखादी ऑर्डर पेअर जर घेतली तर त्याचा सेकंड जो इलेमेंट आहे तोच इलेमेंट फर्स्ट इलेमेंट पाहिजे दुसऱ्या कुठल्याही ऑर्डर पेअरचा. तशी ऑर्डर पेअर चेक करायची आणि ते 2 इलेमेंट कॉमन इलेमेंट कॅन्सल केल्यानंतर जे काय आन्सर येईल तुमचं ते आन्सर जर गिवन रिलेशनमध्ये असेल देन ओनली वी कॅन से दॅट रिलेशन इज ए ट्रान्सिटिव्ह रिलेशन. लाईक हिअर first order pair is 1,2 and here this second element is 2. So we have to find any another order pair from this relation only whose first element is 2. Yes, so here 2,2 is available whose first element is 2. So now 2 we will get cancelled and you will get answer as order pair 1,2. And that order pair is available in this relation R. That's why this relation is a transitive relation. Okay. So likewise, check for relations S and T and tell me whether these are transitive relations. So first check for relation S, then we will see for T. Check for each and every order pair. Hello, are you able to solve this? तुम्ही सॉल्व करणार आहे की मी सॉल्व करू? Okay, we will solve. So here in this relation is first order pair is 1 comma 2. Okay. Now we have to find out such a order pairs whose first element is 2. Okay. So 2 comma 3. Here first element is 2. So we can consider these two order pairs as 1 comma 2 and 2 comma 3. So this 2 2 will get cancelled. You will get answer as order pair 1 comma 3. Now check whether 1 comma 3 belongs to S. Yes, 1 comma 3 is here. So up to this relation is transitive. Okay. Now check for the next element or next order pair, and that order pair is 2 comma 3. Okay. Now check whether there is any another order pair whose first element is 3. But there is no such a order pair whose first element is 3. That's why we are going to skip this order pair. Now check for next one, 1 comma 3. Again check whether there is any order pair whose first element is 3. No, that's why again we are going to skip this order pair. Now check for the last order pair, that is 2 comma 1. Now check whether there is any another order pair whose first element is 1. Yes,
1 comma 2.
there is one order pair. Yeah, 1 comma 2. That's why 2 comma 1 and 1 comma 2. So if you consider these two order pairs, 1 1 will get cancelled. You will get order pair 2 comma 2, and which is not present in this relation. So likewise, if you consider 1 comma 2 and 2 comma 1, this 2 2 will get cancelled and you will get 1 comma 1. So this order pair is also not available in this given relation S. That's why S is not transitive. Have you understood?
Yes, ma'am.
Yeah.
Yes, ma'am.
Okay. Now last one, T is given and that is consist of one order pair 1 comma 1. आता हे ट्रान्सिटिव्ह आहे की नाही कसं चेक करणार? 1 comma 1. आता आपण चेक करणार की अशी कुठली ऑर्डर पेअर आहे का ज्याचं फर्स्ट इलेमेंट 1 आहे? येस, that element is 1 only, that is 1 comma 1 1 comma 1. So again 1 1 will get cancelled. You will get answer as 1 comma 1 only. So that order pair is available in this relation T. That's why T is a transitive relation. Okay. So in this way we can check for transitivity of any relation. Okay. So again some examples are there, but I think we will see those examples next lecture. No, now we have to start the revision. Okay, from next lecture onwards. Now clearly tell me, revision means what? What part you want from start to end, or some bits only? What you expect for this revision?
Ma'am, explain topic wise and give us some time to write down the notes in lecture
Write down.
itself.
Okay, just tell me whether other faculties are giving time for this writing purpose.
Ma'am, actually yesterday one meeting was conducted with Maske sir. So we have told him our problem that almost 6 subjects are there, and for each subject at least 2 to 3 chapters are completed, and we are still on the first chapter. So we need time to write up the notes so that we can at least link up with the teaching which is going on.
Yes, your concern is correct, but we are providing notes to you after completion of lecture. So from those notes you can take down, no? And you can complete your notes.
Ma'am, actually lectures are from 10 to 4. When we write?
Yeah.
Yes, ma'am, and 6 subjects are there. So
Yeah, your concern is also correct. I will discuss with Maske sir, and accordingly we will continue from first chapter.
ma'am, otherwise we will write the like first chapter, we will write down the notes, and then you can take revision continuously for like 1 hour or 2 hours, so that we do not have to stop in between for writing.
Okay.
But
That
ma'am,
is
till the
also
time we write the notes of the first chapter, please don't teach anything new so that will not get missed.
just tell me what we should conduct on next lecture.
Just revision.
Just
Revision, ma'am,
revision.
of first chapter, yes.
Okay. So we will finish the revision of first, third chapter. Then we will continue with the fourth chapter. Is it fine?
Yes, ma'am. Yes,
Yeah.
ma'am, okay.
Okay. So we will take present now. Just a minute. Okay. So before presenting, I want to ask you one question. So whatever we have seen till now, have you understood or what? No doubt that I will repeat that part. That is not issue. But I just want to know whether you have understood that part or what.
Understood, ma'am.
Okay. Mm. Presenting roll number 1,
Yes, ma'am.
2,
Yes, ma'am.
3,
Yes, ma'am.
4,
Present, ma'am.
5,
Present, ma'am.
6,
Present, ma'am.
7,
Present.
8,
Present.
9,
Yes, ma'am.
10. Roll number 10. Okay. 11,
Yes, ma'am.
12, roll number 12, 13, 14,
Yes, ma'am.
14 is present. Okay. 15,
Present.
Yes.
16,
Yes, ma'am.
17, 18, 19,
Yes, ma'am.
20,
Yes, ma'am.
21,
Yes, ma'am.
22,
Present, ma'am.
23,
Present, ma'am.
24,
Present, ma'am.
25,
Yes, ma'am.
26,
Present, madam.
27,
Present, ma'am.
28,
Present, ma'am.
29,
Yes, ma'am.
30,
Present, ma'am.
31,
Present, ma'am.
32,
Present, ma'am.
33,
Present.
34,
Present, ma'am.
35,
Present, ma'am.
36, 37,
Present.
38,
Present.
39,
Present.
40,
Present.
41, 42,
Present.
43, 44,
Present.
45,
Present.
46, 47,
Yes, madam.
48,
Present.
49,
Yes, ma'am.
50,
Present.
51,
Present, ma'am.
52, 52, 53,
Yes, ma'am.
54,
Yes, ma'am.
55,
Yes, ma'am.
56,
Yes, ma'am.
57,
Yes, ma'am.
58,
Present, ma'am.
59,
Present, ma'am.
60,
Present, ma'am.
61,
Present, ma'am.
62,
Present, ma'am.
63,
Present, ma'am.
64, 65, 66,
Present, ma'am.
67,
Yes, ma'am.
68,
Yes, ma'am.
69.
Present, ma'am.
Okay. Now check absent numbers. Roll number 12, 13, 17, 36, 41, 43, 46, 52, 64 and 65. So these are the today's absent numbers. Okay. So thank you. Today we are going to stop here. Yeah.
Bye.